All right, everybody, we're back for the final coffee talk today, and almost the final for the conference. We just have one tomorrow morning, so 2 tomorrow morning now. Excellent, 2 events tomorrow morning. Here we go. I'm being informed as I stand here, or sit here. So our final presentation today, I'll hand straight across to you, Mark.
Great. Hi, everybody. Can you hear me okay? Yeah? So my name is Mark Linesch, for those of you who don't know me, and I work for Mark Potter in the CTO office and labs. And my job is fundamentally strategy, working across the different organizations, and primarily on what we call Horizon 2 and Horizon 3. Think about the first 18 months, really Horizon 1, where we're actively, kind of enhancing our roadmaps and these kinds of things. Horizon 2 being kind of beyond the 18 months into 36 months, where we're doing advanced development, proof of concepts, incubations into different things. And then Horizon 3, which is more of your, kind of research-oriented stuff. And so I get the fun job of working with just some incredible researchers and engineers on the future, quite frankly. And I think as you come to a show like this, you see some of the results of some of those talented engineers, some of those talented product marketing people who are, out there trying to, make headway in terms of our next generation compute and storage and networking, Gen 10, some of the security environments and those kinds of things. The 3 key vectors that we're kind of working on right now, number 1, of course, would be hybrid IT and continuing to kind of enhance the overall efforts there. Number 2 is, of course, the work in the intelligent edge, and we're working some advanced development areas there. And then 3 is really memory-driven computing and the analytics, machine learning, artificial intelligence, algorithms and frameworks that really are starting to get turbocharged by these kinds of systems. And so, I'm excited to be here. I'm excited to dialogue with you guys. Let's make it really informal. It's the end of the day, and I'm standing between you and a beer. So, let's kind of open it up and see what kind of questions you have about either where Hewlett-Packard Enterprise is going, what some of our technology strategies are for the future, or whatever you're interested in.
I have a question regarding Gen 10.
Mm-hmm.
So I was checking the website, and there's a new microserver available with the Gen 10 generation, but it's not as secure as the bigger option that we have, all the ProLiant servers. So, I'm assuming this server is intended to the branch offices and probably home users, but is HPE trying to get into every house as possible, or the microserver is intended for something else?
My understanding is, and I'm not an expert on the microserver, but my understanding that it is for a small business, right? And that it's really designed as a service experience for a small business. So integrated gateway, integrated internet capabilities and the like. And probably the reason why it doesn't have the Gen 10 security is probably a cost point issue having to do with ILO silicon. If you remember from the discussions you've had on Gen 10, right, the secret sauce in the security and being able to create that root of trust, if you will, is being able to fingerprint the firmware with the ILO silicon throughout the supply chain, the bring up and the lifecycle management. And so my assumption would be that that microserver does not have an ILO chip in it, and so it probably doesn't have the new security features that the rest of the Gen 10 platforms have.
But that's going to change how the future of the data center is going to show? Are we going to be using, instead of 1 unit servers, to start using microservers and just stack them, everyone in the data center, in the future of the data center?
But that's not where the microserver is targeted at. The microserver doesn't go in a data center. It goes in a cupboard at a small business or branch office.
That's true. But if you think on the future of the data center, we are thinking about segregation. And if you can say the future of the data center is not having 1 or 2 unit servers, it will be having small servers with the same capabilities, but very segregated by every customer.
Well, I think there's lots of different ways to skin that cat, right? In a large data center and in an enterprise, you might want to skin that cat with multi-tenancy or other types of composability types of functions, synergies and those types of things. But I think you're right. The microservice is really targeted at a very small business who has absolutely no IT whatsoever, and is really designed to be managed and operated in a very simple and easy way, right? Now, I was out on the show floor, and one of our partners out there called Mindbox is doing some pretty interesting things. They're basically taking those microservers, and they're creating a peer-to-peer storage area network like a Dropbox with security supplied by blockchain, so that they can create a secure peer-to-peer network of devices that can share their storage resources. So for instance, they can use it as a small business could use it as a Dropbox backup and recovery capability, and you're sharding across sort of multiple peers, and so you've got a lot of resiliency here. But the really interesting piece about the business model is that if you have excess storage capacity, you can provide it to somebody else and sell them that excess storage capacity through Bitcoin. So these microservers today are targeted directly to small business, but these peer-to-peer networks and some of these other kinds of capabilities are very interesting. I don't disagree with you that there's lots of different ways to think about kind of those servers, but that microserver that we're talking about definitely is not designed for data center environments. Okay?
Yeah, the data center version of that vision of scaling out lots of little servers is Moonshot. And that's one enclosure with enterprise class features, but lots and lots of little modular servers inside it.
Cool. Other questions or thoughts? Yeah, yes, sir.
I'm curious about HPE's data center strategy in terms of data center switching and networking, and how that might tie into the whole composability initiative and also initiatives like NewStack.
Yeah, I think the data center strategy that we've had in the past has been a little bit reset, right, with the spin out of the HCA stuff from China and the Flex Fabric stuff. And so, really we're continuing to sell the Flex Fabric line as a traditional switching capability, right? But a lot of the focus today is really on our partnership with Arista and software-defined networking, and looking at then how do we tie that software-defined networking closer into some of our, one view and composability kinds of features. And I think that there's other opportunities on the horizon. I think, did you guys take a look at the new Aruba switch, for instance, the core switch? That came out of some of the work that we've done in open operating systems, right? And that's an entire software-defined platform, open APIs, REST-based APIs. You can use tools like Chef or Puppet to do configuration management and the like. And so we have a lot of different technologies. We've got traditional Flex Fabric capabilities for some of our enterprise customers who want that. We've got these new, kind of Linux-based open operating systems like what we just announced with the Aruba core switches. And then we've got this deepening partnership with Arista for software-defined networking. And I think what you'll see moving forward is that partnership started out as primarily a go-to-market partnership, but there are really good technology opportunities for us to better integrate the Arista capabilities into some of our composability strategies, some of our provisioning strategies moving forward.
Could you just provide a little bit more context on the nature of the relationship with Arista?
In what way? I mean, by what do you mean by the nature?
So when you say go to market, does that mean if you're talking to a client and they happen to need they're looking at Leaf Spine. You say, oh, well, we have a partnership with Arista, and here's how we can do some things together, or what is this?
Yeah, absolutely. I think part of what we're asking our partners in our direct sales force to do is to kind of qualify a customer as to, are they a customer that wants open networking? Are they a customer that wants software-defined networking? Are they a customer that wants traditional networking? If they're a customer that wants software-defined networking, then we're going to steer them to the Arista partnership, and we're going to kind of work jointly with Arista to kind of land that customer and to make sure that those networking products and capabilities are working well with those in those environments. And these types of partnerships, quite frankly, are things that we do pretty well. We do a pretty good job of working with companies like an Arista, like a Mesosphere, like a Docker, and doing both joint engineering, joint R&D, joint innovation, but also joint go-to-market. Okay. Other questions? I know this is a tired crowd, right? I can already see that. Yes, sir, Mr.
A little bit closer in on networking, silicon photonics. Well, photonics in general. You guys have the X1 VCSEL-based technology today. Some farther future silicon photonics. We heard earlier today that I think the hyperconverged chassis are plumbed for fiber, although they're not using it yet. Can you give us some idea of? It seems like one of the early technologies that'll be commercialized from the machine. When will we see fiber more widely deployed in mainstream servers, hyperconverged?
Well, that's the current $1 million question within Hewlett-Packard Enterprise, and the discussions we're having with our different product divisions. I think that X1 chip and some of the capabilities there, we need to commercialize not only that chip, but the kind of switching technology associated with that. And so, as you said, Synergy is plumb for photonics, and we're in the process of the way that this works between kind of our advanced development and labs area and the product divisions is the product divisions go through a very kind of structured way to introduce a new product, and it's build a concept, then do a marketing requirements document that makes sure that you've got the right features that meet and fit the customer requirements, and then do what's called a plan of record, which is the actual funding of that product and into a new product integration cycle, right? So where we are with our business units today around photonics is we're looking at these different concepts, and so we're in that first phase, if you will, of concept development. So I'm thinking probably sometime in 18 or early 19 will be the sweet spot for our first introduction of some of those photonic capabilities. And it may be that we'll actually do photonics earlier than that using kind of industry standard parts, and then follow that up with an X1 more organically developed capability from Hewlett-Packard Enterprise. So we're still in that process of kind of working through those concepts and looking at the different alternatives. Okay.
So where do you see the intelligent edge picking up over the next few years? I mean, we've seen a little bit of the IoT and the edgeline servers being deployed out. What sort of direction do you see that? Is it more density of computed edge, or just there's going to be more things out at the edge with compute in them?
Really, all of the above. I've been really pleasantly surprised at, quite frankly, the amount of business, the amount of engagements that we're seeing across our mobile edge, wide area network edge, and industrial edge. We have today, we just completed a proof of concept and are now signing a fairly significant agreement with a major industrial company automating 400 of their factories around the world with edgeline gateways and and devices. And so I think what you're going to see is more and more computational power at the edge for a particular class of use cases. So if you think about separating use cases, there's use cases that you need to ingest a lot of and aggregate a lot of data, and it's so much data that you don't want to send it back to the cloud. So you want to analyze it at the edge, and not only analyze at the edge, but potentially it may be a real-time response. And we see that a lot in process industries, right? Where what you'd like to be able to do is do some type of capture of anomalies or different parameters that are out of whack, be able to do that analytics very, very quickly, and then respond back to the process pretty quickly. Other applications, like smart city applications, where you're connecting, let's say for smart trash removal or smart lighting or those kinds of things, or using low power connectivity, low RAN and things like this, and they don't have a very large data rate, so it's going to be thing to aggregation to the cloud type of a thing. So we really have to kind of separate the applications that require computation at the edge from the applications that maybe don't require computation at the edge. But applications like harsh environments and industrial applications, oil rigs, these types of things are definitely part of that. And I'd say something else about that, which is that what we're going to be seeing here in the next few years is we're going to be seeing a real dance between the edge and the core. Okay, and think about the core is where you, let's say, train a next generation machine learning model using, a whole bunch of clusters and a whole bunch of data. You're going to want to then containerize that model and push it down to the edge. When it's down at the edge, if it's a real-time response type of an application or a big data application at the edge, then you're going to want to do your inference at the edge. And increasingly, we're going to have it be more machine-like, because you're going to want to put that entire model into persistent memory so that you can get the response times that you're looking for. And you may even have acceleration at the edge through a GPU or an FPGA. So we're looking at these next generation edge environments, and we're saying, really, the sky's the limit to the extent that we can build a variety of different either gateway or computational devices that will fit a lot of these different use cases. And then the other part of that is being able to do the data and model management between the edge and the core, right? And so as you execute a model at the edge, you find out that the model needs some additional training, then you retrain at the core, push the model back to the edge, and keep on going.
Yeah, so you're doing sort of anomaly detection around your model at the edge. As a result of anomalies, you'd have to develop a new model and then distribute that back.
Correct. And one of the things that's on the show floor that you guys ought to take a look at is something we call distance deep learning, and a protocol that we use to collect those anomalies and then send those to the core for retraining. And that's an innovation that right now is in a POC status in our advanced development, and that hopefully will find its way into a productization cycle over the next 12 to 18 months.
So, yeah. So I've been hearing talking about compute power, photonics, workload, storage, but I haven't heard anyone talking about energy efficiency. For the future of the data center, it's important to have a storage, but I feel that the conversation has to be driven about energy efficiency and how we are going to be powering all these powerful machines that we are going to be having in the future. What do you think about it?
Oh, it's a great question. In fact, one of the key drivers to our machine research and to next generation memory-driven computing is the fact that we cannot sustain the energy as these data centers around the world, as the cloud and as IoT continues to mature and become more pervasive. And so part of what we're doing with photonics and part of what we're doing with persistent memory is very, very focused on energy savings. And let me give you some examples. Today, what happens is you're shuttling data back and forth between the hot and the safe, right? And going from the disk drive to the SSD to the memory, working on the problem, and then spinning it back out for checkpointing and things like this. With and DRAM is a continual refresh, and so you're not only shuttling data back and forth, which is very energy intensive, but DRAM, you're always refreshing that DRAM, and that's energy intensive. With persistent memory, things like 3D XPoint, the memory version, Memristor, and other devices that are be coming down the line, there is no refresh cycle, okay? There is no power that needs to be applied to a Memristor, with data. It's a persistent type of a thing. So you're saving lots of power because of the no refresh, and you're saving lots of power because you're holding the data set in memory and you're not going back to disk or to SSDs and shuttling data back and forth. That's on the persistent memory side, and that's a big deal. Number two way to save memory is that copper is hot, light's not. So as the world moves toward more and more photonics, we'll get a big energy savings with regard to shuttling data between the nodes and across the data center. The third aspect is that when you hold a model into memory, one of the things that you can do is, instead of recomputing the model, you can just change the pointers to a lookup table and get the difference, right? And so we've proven out with the machine that in a Monte Carlo simulation, by rethinking the algorithms, and instead of recomputing the random walk in a Monte Carlo situation to get higher and higher accuracies for derivative pricing, that we can just change the pointers in memory, do a lookup table, and save enormous amounts of recompute energy for these big data and simulation kinds of applications. So you're going to see huge huge energy benefits as the world moves toward persistence, photonics, and these new types of in-memory types of applications. Sir.
Hybrid cloud has been a clear part of a HPE message for the last couple of years. I'm wondering why only now we're learning about an orchestration tool that can really enable that in terms of NewStack, and why that wasn't part of a strategy from day one.
That's an interesting one. I guess my perception is that HP has been a pioneer in thinking about hybrid cloud and thinking about the fact that one size doesn't fit all, that quite frankly that you're going to have some of your IT services in a public, some in a private, and what you're really looking for is an ability to manage all of those IT services from a cost, from a business control, from a security, from an operational perspective. And the reason I think that you're seeing NewStack now is because our customers are starting to become very familiar with the notion of hybrid and are now starting to say, I need these types of tools as I move into my more focused hybrid strategies. To date, we talked a lot about hybrid, but I didn't see too many customers actually executing a hybrid in a pervasive way. So I think that the timing actually is pretty good for NewStack in terms of enabling our customers on their unique hybrid journey. I will tell you also that the evolution of the industry's thinking on hybrid has come a long way. We used to define hybrid as, well, we can burst into a public cloud, right? And then it was like, well, we can get visibility across a couple of different clouds. And now we're saying, well, look, you can stand it up in Google and Amazon and Azure, okay? And we can connect all three of those IT service delivery capabilities with your existing data center capabilities and bring that all together into a unified dashboard for control, for operations and the like. And it's somewhat unique. I don't know that there's another tool out there that is as aggressive in kind of thinking about this as NewStack is. And we've gotten great customer feedback and interest on that. Now, it's still early days, but we've gotten feedback that this is a capability that our advanced customers who are on that hybrid IT journey are really looking for, and they haven't found necessarily the right tools. And so we're fairly hopeful that this is going to be an important addition to our hybrid cloud strategy. But time will tell. Okay?
So I got to say, I've had customers, I have a specific customer in New Zealand, and maybe you should be testing this in New Zealand 5 years ago, but 5 years ago a customer said, what I really want is a console for my business units where they can choose where they want to deploy their application, and that there's some governance around. They have to declare what kinds of data they're holding, and that will allow me to constrain them about where they can deploy this. And this is exactly the sort of things that I understand as NewStack. Customers in New Zealand a specific customer asked me for this 5 years ago.
That's a great comment. I mean, I think the other thing about NewStack is that infrastructure as a service really targeted your operations folks, right? For the most part, they sort of, kind of said, okay, well, look, IT, I want you to, sort of give me IT services faster. And the operation guy said, well, look, I'll give you VM vending, or I'll give you, kind of minimal cloud kinds of things. But your point is very well taken, is NewStack is really designed for three personas. It's designed for the line of business persona who cares about business controls and who cares about, being able to stand up separate workspaces for different things. It's designed for the DevOps community to bring their tools in and to kind of quickly build their pipelines and these types of things. And then it's designed for the operations people. And so I think we've learned a lot about how to make this stuff practical, make it real world, and make it valuable for people. And that's what we're doing to kind of envision things like NewStack.
So I think we've mostly been talking about things that are on the horizon too, that are going to come out in the next 2 years kind of phase. What are the exciting things a little further out on the horizon? What kind of things are you still trying to form into a real idea that are still a little further out?
Well, that's a great question. I think that further out are cognitive computing chips that can better meet the engagement with the analog world. We have a couple of long-range government contracts that allow us to do fundamental research on how to use resistive technologies, memristor technology, to do analog to digital accelerations that are fairly significant. The whole area of deep learning is exploding right now, but there's still a lot of work to do around kind of making deep learning something that is accessible to your average enterprise and that they can kind of bring into focus. One of the things you saw in the labs area or you might have seen in the labs area, is our deep learning cookbook, which basically looks and says, okay, well, for this use case, let's say real-time video analytics, right, which a lot of our customers are interested in, then you should use this deep learning framework and then this configuration of Apollo systems to train it on and this stuff to inference it on. So I think that both some of these cognitive computing accelerators, some of the deep learning capabilities that we're doing, some of the work that we're doing long-term on exascale computing, where the governments around the world are saying, what's next in terms of being able to get to petabyte scale and these types of things, is work that combines our high-performance computing with our machine research and says, well, how do we stand up a petabyte and just thousands and thousands and thousands of cores, and how do we operate that at scale? And so there's lots of those types of things. You've seen out in the show floor us doing some incubation work on blockchain, right? Now, the work that we're doing with blockchain today is primarily in the financial industry. We did a session earlier today with one of the customers in your favorite place of Australia, Commonwealth Bank of Australia, and we're incubating a proof of concept with those guys on blockchain. But blockchain can be used for a number of different use cases, including a lot of use cases in the IoT space. And so that'll be one of the things over the horizon as IoT starts to mature a little bit that you're going to see a lot of interest in, is a machine-to-machine blockchain capability so that you can transact value. So those are some of the things on top of my mind anyway.
Cool.
So, Mark, when you think about where things are going and some of the changes, several of the things that you articulated take a pretty demonstrable shift away from the classic HPE kind of creed and history and focus, right? It's moving away from infrastructure, it's moving away from that core hardware piece and moving more toward applications and software, right? Especially as you start talking about machine learning, you start talking about cognitive, you start talking about deep learning. How exactly is that going to happen within HPE? And as part of that, that's a totally different customer than HPE is typically engaging with. So how are those two things going to resolve each other as we go through time here? Because it's great to talk about it, but my concern would be, how are you going to be able to execute on that on both fronts?
I have concerns about execution every day, so it's not a new subject for me, but I would disagree a little bit. I think that HP has more software developers than we do hardware developers, but let's take the area of machine learning and deep learning, okay? We have an approach to that I'll kind of lay out for you, and it's really kind of 5 things, right? We do fundamental research on kind of deep learning, machine learning kinds of algorithms, and we do a lot of research on algorithms, quite frankly, and so this is an area where our labs people have historically added value and the like. We do fundamental work around VLSI, quite frankly. We are doing the chips for photonics. We're doing the chips for next generation ILO. Okay, we're doing the chips for network acceleration and these kinds of things. And this is a core capability that most people don't even know exists within Hewlett-Packard Enterprise.
So let me clarify then. When you talk about machine learning and cognitive and deep learning, are you talking about specifically that as a wrapper to infrastructure, or are you talking about it in the broader sense of, I have business applications that are trying to engage in deep learning and machine learning aspects?
Yeah, so our model...
Those are different.
I understand. Our model is we're going to enable deep learning, machine learning for our customers through point next services, discovery services, road mapping services, through injecting deep learning into our own management and automation capabilities. An example of that is Niera for the ClearPass policy and behavioral analytics piece. We're going to be creating partnerships with the deep learning frameworks, and we recently announced a partnership with NVIDIA around their complete frameworks and capabilities. And we're going to be building optimized platforms and accelerators for deep learning and machine learning applications. And we've announced some work that we're doing with the Apollo platforms in that particular area. So optimized platforms, deep ecosystem partnerships with the frameworks that are out there, both the open source frameworks and the vendor specific frameworks, injecting this machine and deep learning technology into our software defined infrastructure management automation capabilities, and then helping our customers through Point Next and through our SI partnerships to actually build out use cases and those types of things. We're probably not going to do a whole lot of application development and those kinds of things, but we're going to enable these deep learning use cases and applications through our services arms and through our partnerships with SIs. That work? Yep.
A little more pedestrian question. When you hear it, you'll understand why I phrased it that way. In the past 18 months, we've seen the cost of flash drop, and we've seen the densities go up. Of course, magnetic media is nowhere near as quickly growing. We still have 6, 8, 10 terabyte drives on the 3.5-inch form factor. HP has got to have their thumb on the pulse of where the fabs are, when we're going to theoretically hit that inflection point, or better stated, intersection, where spinning disk has the same cost density that flash has, and we're in forecasting that for strategic purposes. What's next? We already seen things from HP like a 16 terabyte, 2.5-inch form factor SSD, which we'll never see that level of density from spinning disk. There's just, I think it's literally physically impossible for that density for mag media. What are the thoughts for the data center side when we really are discarding spinning disk and we're not dealing with the space, the heat, the energy, and it's all solid state?
I'm not close enough to give you a real practical, definitive answer on that, and let me tell you why. I predicted that mainframes were going to die about 7 years ago, and they're still around, right? So I'm not one of these people that calls the death of magnetic and spinning media. I think it's going to be very useful for cold storage for quite a few years. But would I be betting on the growth of magnetic and spinning media? I would not. If you think about where we are today with SSDs, and then you project that they're going to get faster and more denser, and they're going to get into multi-packaging, and they can stack them and all that kind of wonderful stuff, I think we're going to continue to see all flash all the time. And then just around the corner from all flash all the time, and we're already seeing that with our 3PAR and Nimble teams, we're going to see memory-driven, what they call storage class memory, which is near the speed of DRAM, okay, and you can do load store operations. And when that goes persistent, when 3D XPoint enters the picture in the second half of 18, or whenever they deliver that, when Micron delivers their capabilities, when Samsung delivers their capabilities, when Memristor enters the picture, then we're going to start to see a new tiering happen. We're going to start to see very fast, high bandwidth memory attached to an SoC, but then we're going to see this, abundance of storage class memory that we can do load store operations with, and then we're going to see another tier of very fast SSDs, and magnetic media is going to continue to dwindle in terms of its place in the hierarchy, right? And that's because of its energy, that's because of its reliability, and as you say, it's going to become increasingly because of its price performance. I just can't give you a date. Now, some of our storage guys could probably give you a more precise date, given the fact that they follow it in a weekly, monthly time frame. So, but that's the best I can do.
Well, I think we're drying up on questions for you, and everybody's feeling very fatigued and brain full and somewhat woolly.
Yeah, I believe that. Yeah. Well, I just want to thank you guys for hanging in there and for your interest and your questions, and particularly for your feedback. I think one of the things that's so important for us is that you guys continue to challenge us and continue to provide feedback in what we're doing right, what we're doing wrong, what you don't understand, what you disagree with, right? Now, all your disagreements, send them to Chris, okay? All your praise, I'll be happy to take that. But thank you so much for all your time and your efforts, okay?
Thanks, Mark, and we'll be